For Chapter 6, we're going to be talking about nomenclature or naming of inorganic compounds. It's important that we have a systematic naming of compounds because common names are not based off chemical composition, and it'd be really hard for someone new to the field to understand what we're saying if we just kept using common names. So nomenclature is a good thing to have. So for example, N2O is nitrous oxide or laughing gas. But the systematic name, if we follow nomenclature, would be dinitrogen monoxide. If you knew the systematic formulas of how we name stuff, if I say dinitrogen monoxide, you would know that it would mean N2O. However, if we just said laughing gas, not everybody knows what laughing gas formula would be. So another example would be water is H2O and ammonia is NH3. So common names reveal nothing about the physical and chemical properties of a compound. What we want to learn is nomenclature here. So common names are used because systematic names are too long and technical for everyday use. But it's still important for us to learn how to name things in the system. So for this case here, example for CaO, this is Ca for calcium, O is oxygen, but when we name it, we call it calcium oxide. If I said calcium oxide, everybody would know it was CaO, but if you said lime, some people might think, well, is it the lime that's a fruit, or is it lime that's CaO? Most people would think of lime as the fruit. So what we prefer is systematic names that precisely identify the chemical composition of the compounds we are referring to. So what system we use, it was devised by IUPAP, International Union of Pure and Applied Chemistry. So here's the naming flowchart. We will focus on inorganic compounds. Inorganic compounds generally have metals in it. Organic typically means carbon and hydrogen, that kind of stuff. So inorganic means it has some metals involved in it. So if we have number of elements present, if a one type of element, we call it an element. And then if we have two types of elements combined together, we call it binary compounds. Three or more types of element, we call it polyatomic compounds. So we'll have each section that we learn about naming here. We learned about elements in the previous chapter already. Based on what we learned about pure substances. So we'll be focusing more about binary compounds and polyatomic compounds here. So for elements and ions, the formula for most elements is the symbol of the element. So sodium is Na for the symbol. That's unusual. That's because sodium actually means the old name for sodium is natrium. So Na symbolizes natrium, but we still use the old symbol here. So 7 elements exist as diatomic molecules, which is pretty cool. We have hydrogen, H2O2, oxygen, nitrogen, fluorine, and chlorine. These all exist as diatomic molecules. That means it has 2 of each. So 2 H's, 2 O's, 2 N, 2 F, and 2 Cl. And when we write it, we put a 2 on the back of it and we use a subscript. So these are gases. Bromine, Br2 is a liquid, and I2 is a solid. And then we have some exceptions here. We have some of them exist as multi-atom molecules under standard conditions where sulfur is going to be S8, phosphorus is going to be Sp4. So a charged particle is called an ion. We talked about cation and anions earlier in the previous chapter, and it can be produced by adding an electron to make an anion or removing electrons to make a cation from a neutral atom. So let's take a look. So we have potassium atom. It has 19 protons and 19 electrons, and potassium ion can be formed by removing one electron. So our potassium ion would be a cation because we take away one electron. Neutral atom, take away, so minus one negative, which comes off right here. The leftover charge is positive 1. So this is a cation here. So cation is anything that loses an electron. Okay, so atom loses electrons, we call it cation. So an atom may lose more than one electron. Sometimes they prefer to lose two, sometimes they lose three. And whenever they lose two, they get a 2 plus. If they lose three electrons, they get a 3 plus charge. So potassium will turn into K plus, potassium ion. Magnesium will turn into Mg2 plus, we call it magnesium ion. Aluminum, we'll call it aluminum ion. So really, the ion's names is the same as the symbol of the element. So let's talk about anions here. For anions, we want to say that any neutral atom that gains an electron will form an anion. So we have chlorine atom plus an electron, 0 plus -1 equals to -1 charge. So Cl negative ion, this is chlorine. And when it turns into an anion, we will call it chloride. A neutral chlorine atom contains 17 protons and 17 electrons. A chlorine ion, which will be called chloride, we'll see the name later, is formed by adding one electron. So you put an extra electron in there, we have Cl negative ion. An atom may also gain more than one electron. For example, oxygen likes to gain 2 electrons to get oxygen ion, which is also an anion here with -2 charge. So let's take a look at the naming for a little bit. So naming of these anions here, we use the same parent element but change the ending to IDE. That's why I said when fluorine was turned into an ion, we call it fluoride ion. Chlorine will turn into chloride ion. Bromine will turn into bromide ion. Iodine to iodide. Oxygen to oxide. Nitrogen to nitride. So IDE means just the element and then turning it into charges. So how do we know who wants to do what charges? So in the next slide here, it predicts the ion charge from the periodic table. So one thing you want to know is this is group 1, so the first group here, and the second group, the first group is always +1 charge. You see it's all +1 because it's 1. If it's group 2, it's always +2 charge. Okay? And then we have group 7 right here. It's always going to be -1 charge. Group 6 will be -2 charge. Group 5 will be -3 charge. And then we have some of these different ones here. Aluminum, we say it has 3 plus charge. It doesn't change. It's always 3 plus. Zinc is 2 plus. Silver is 1 plus. That's silver right there. And then these guys here kind of have multiple charges. Okay, so metals in general form cations. If you take a look, see this is plus, and that's plus, and these are plus, plus, and all this plus, because this all steer here is the metal side. Obviously, this is the main group. This is transition metals right here. Aluminum is still under metal. Okay, metals form cation. The charge is usually equal to the group number. So group 1 is +1, group 2 is +2, and then group 3 is +3. And then obviously the anion is a little bit different here because the anion is going to be in negative charges. All right, so let's talk about anions. Anions here that we were talking about earlier, we said we had negative charges is because we want to say whatever 8 is the best, it has no charge, everybody is neutral. And then if it's group 7, 8 minus 7 will give you a charge of -1. 8 minus 6 will give you a charge of -2. 8 minus 5 will give you a charge of -3. So that's how we know the charges. Okay, so that's just a general idea there. It's because everybody wants to have wants to be like group 8. So if group 8 says fluorine's like, well, I have 1 electron less than this guy over here, so I want to add an electron. So that's why when you add 1 electron, it always have 1 negative charge here. So group 7 is always going to be -1 charge. And then group 6 is going to be -2 charge, always because it's 2 away from 8. And then group 5 here is always going to be 1, 2, 3 away from 8, so it's going to be -3. So a formula that's easy to remember for anions is 8 minus the group number it's in. So how do we write formulas from names of ionic compounds? So ionic compounds name will have both a cation and an anion because this cations are generally metal, anions are generally non-metal. For example, NaCl is going to be Na plus and Cl minus. So Na cation, sodium ion, and chloride anion. The ionic compound will have a net charge of 0. The sum of the charges in an ionic compound equals to 0. So for example, we have sodium bromide, sodium Na plus, Br minus, because Na was in group 1, Br was in group 7, 8 minus 7 is -1. So, and if it's +1 and -1, so we have the charge turn out to 0, so it's NaBr. And then if you have potassium sulfide, we have K plus potassium plus ion, S2 minus sulfide ion. And then you see how this is -2 and this is +1. So to make both sides the same to equal to neutral, you need 2 of the potassium. So 2 of the potassium and then -2 is 0. So I have to write K2S right there. If it's zinc sulfate, we know zinc is 2 plus ion, and SO4, this is a polyatomic ion, but it's SO4 2 negative. If it's 2 plus and 2 negative, they can combine acids to give you 0. So you can just write, in this case right here, zinc sulfate. SZnSO4, combine as is because the charges are the same, opposites. And then if we have ammonium phosphate, which is NH4 positive, so +1 charge, and then PO4 3 minus charge. So this is +1, and that's 3 negative. So for me to get a total of 0 neutral compound, I would need 3 of this positive to balance out this 3 negative. So in this case, that's why I write NH4 3 PO4. So NH4 in brackets, that means 3. That means there's 3 of these NH4 right here in here. So in this case, another thing that people always tell you to do is you can crisscross the charges. So like if it's 3 and 1, this one will have 3, this one will have 1. See how this is 2 and 2? You don't have to crisscross because it's the same. But if it's 2 negative and +1, crisscross. So this K will be 2, S will be 1. That's why you see that. So the crisscross method works. So you see here, I have Al 3 plus and CrO4 2 negative. So I have 3 positive and 2 negative. For me to have a balanced charge, if I have 2 of these, this will be -4, and this is -3. That's still not the same. So the common number is 6 here. So I need 2 aluminums to be 3 plus, so that will be 6 positive. And then when I do my chromium, I will have 3 of them, so I can get 6 negative, and when combine, we get 0 charge. So when you take a look here, and again, if we do the crisscross method, Al will be 2, chromate right here would be 3. So we have Al2, and then CrO4 and brackets here, 3. That means we have 3 of these guys repeating itself. So here's the rules for writing ionic compounds. We write the metal ion followed by the non-metal ion formula. So then we combine whole number ratios and give them overall charge of 0. So that's what we've been practicing from that chart. I gave you a bunch of examples. So let's do them. And then for example here, we have barium nitride. So barium is Ba. So if you look at Ba on the periodic table, it's on group 2. So Ba would be 2 plus. Nitride, nitrogen happens to fall in group 5, and it will be 8 minus 5, so 3 negative charge. See how you have 2 and then you have 3, 2 positive and 3 negative? If we did the crisscross, remember, it would end up being Ba3 and 2 right here, because the charges will equal to 6 plus and 6 negative. So here's the next question. It says, write a formula for magnesium oxide. So magnesium oxide, Mg magnesium is Mg. Oxide means it's oxygen. So we wrote it down. We have Mg is in group 2, so it's Mg2 plus. And then oxide is in group 6, so it will be 2 negative if you look on a periodic table. So if I have 2 plus and 2 negative, I can combine as is. So my answer here should be MgO. Now we want to learn about naming binary compounds. Binary compounds have only 2 different elements. It can be ionic or molecular. So if we have binary compounds containing a metal which only forms one cation, we're talking about ionic first. And then the other type of ionic is when the metal can form multiple cations. So if you just remember who can only form one cation, everybody else will form, all the other metals can form multiple cations. Multiple cations will need a Roman numeral in a naming. The one cation guys, they don't need a Roman numeral, okay? So remember, ionic compound is going to be a positive charge and a negative charge. It has to be ions, and generally it will be metal and non-metal combined together. Later on, we'll learn about molecular. So we want to focus on ionic. So let's see. One cation. We name the cation, and then we add the IDE on the anion side. So remember, bromine is bromide, F is, so it's the same name as the anion. Okay, it's just IDE. So who forms just one charge? So remember, everybody in group 1 is +1, everybody group 2 is +2. That's in general. And then we have a few. We have aluminum is always +3, zinc is always +2, silver is always +1, and then you have scandium is +3. If you memorize these, group 1, group 2, scandium is 3, aluminum is 3, zinc is 2, silver is 1. Everybody else will need Roman numerals if they're metals. These guys here, group 1 and group 2, do not need Roman numerals. Aluminum does not need Roman numerals. Zinc doesn't need it. Silver doesn't need it. Scandium doesn't need it. So we want to name the compound MgBr2. First thing we do is cation is magnesium. The anion is bromide. So our total name is magnesium bromide. Provide a formula for sodium oxide. So sodium is Na plus, oxide is O2 negative. So Na plus and O2 negative, we crisscross it, we should get Na2O. That way the charges are balanced. If we want to name the compound Al2O3, we need to know that Al is aluminum, and aluminum is the one that doesn't change its charge, so it doesn't need a Roman numeral. And then we have O here, which is oxygen, but we call it oxide. Okay, so what's the charge for oxygen? It is in group 6, and it will always be -2. If you look on a periodic table, it's in group 6, so 8 minus 6 will be 2. So we crisscross it together. That's why we get Al2O3. So aluminum is fixed charge, right? And we call it aluminum. We don't need a Roman numeral, and we call it oxide at the end. So the only choice that makes sense here is going to be C. Write a chemical formula for calcium sulfide. Calcium is Ca2+, and it doesn't change its charge. That's why it doesn't have a Roman numeral. Sulfide is S, sulfur, and it's because it's IDE, it's S2 negative because it's sulfur in group 6. And then it will have -2 charge because 8 minus 6 is 2. So when you have Ca2 plus and S2 minus, you can combine as is, so our answer would be CaS. So let's name something else with transition metals that can have multiple charges. So earlier we were learning about things that didn't have multiple charges, but we see here transition metals usually have more than one type of cation. Sometimes it's +1, +2, +3, +4, +5. So copper, for example, is going to be Cu plus or Cu2 plus. So it can have multiple charges. So when something has multiple charges, when you put the name in, you put the name of the metal, and then the anion is the same way, but for the metal, you need to put the Roman numeral of the charge. So we specify the Roman numeral. For example, we have Fe3 plus and FeCl3, because Cl is -1, we have to call it iron 3 chloride. So when a metal forms only one cation, like sodium, like what we said earlier, we have group 1 and group 2, and then we have scandium is 3 plus, zinc is 2 plus, silver is 1 plus, um, aluminum is 3 plus, and so those guys don't need Roman numerals. But everybody else, the metal, will need Roman numerals. So when we have Cu plus, we call it copper 1, Cu2 plus, copper 2, Fe2 plus, iron 2, Fe3 plus, iron 3. That's because the old name has to do with cuprum and ferrum. Well, obviously these are the classical names for the ion. You don't need to memorize the classical names for the ions either. But Sn is tin, 2 plus for 2, tin 4 is 4 plus, and then lead is Pb, lead 2, and lead 4. So you see how Sn is stannum, stannous, and stannic. So stannum is, that's why it's Sn. Plumbum is the name for lead. That's why these are the old classical names for the ions. What we need to focus on is just knowing the charge and then putting the Roman numeral of the charge in there. So a lot of times the formula or the name will give you a hint of what the charge is. So it says name the compound FeS. So Fe is transition metal, and we need to know it's got more than one possible charge. And then we need to know that S here is S2 negative. And if it's 1 to 1 Fe and S, that means Fe has got to be 2 plus and S has to be -2. That way iron must be iron 2 because it's 2 plus. So the anion name will be sulfide because it's S2 negative. So our name would be iron 2 sulfide. Next one, we want to try naming CrCl3. So Cr is chromium, and chromium is a transition metal. It has multiple charges. So how do we know what charge it is? If you know that Cl is in group 7, Cl is group 7 and charge -1. So we have Cl negative, but we have 3 of those guys. So if we have this, how many Cr? It says 1 Cr can balance these 3. That means my Cr has to be a 3 plus charge. If the Cr is 3 plus charge, we need to use a Roman numeral 3 for my chromium. So in this case, it will be chromium 3 chloride. So write a formula for the following compound, copper 1 oxide. So copper 1 oxide, copper 1 is transition metal, so it has multiple charges, but it says 1, that means we know it's +1 charge, okay? So if you know oxide is 2 negative, and we have Cu plus and O2 negative, we can just crisscross it and we can say the formula you need, you're going to have to crisscross and say Cu2O, because Cu is going to crisscross with 2 and then O just 1. So we write Cu2O. Write the formula for tin 4 fluoride. So this one says tin 4, that means Sn is 4 plus, right? Fluoride is fluorine and it's going to be 1 negative. How many fluorines do you need to balance with this tin 4? So obviously you need 4, right? That way it'll be neutral. So again, you can just easily crisscross the numbers, so it'll be SnF4 as the answer. So that's for ionic. Ionic compound is a metal and non-metal plus ion, cation, and an anion combined together. So you only have to worry about if the cation is variable charge, then you put in Roman numerals. If the cation is not variable charge, you don't need the Roman numerals. Okay? Let's take a look at molecular compounds. For molecular compounds, it has 2 nonmetals. There's not going to be ions in there. So what we want to do is we use the name of the first element, and then we include the prefix. But if it's just 1, we don't put mono on the first term. The second term will be the second element, and then we follow it up with IDE. And if it's got one of the second element, we will put mono in there. So let's just do some example. We can take a look at the prefixes here first. Mono is 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, deca for 10. You need to make sure you memorize this table, okay? You need to know all your prefixes. That way when you see a compound, when you first see the compound, does it have metals and nonmetals? If it does, I'm going to name it with the ionic way. If it doesn't, I'm going to use my prefixes and naming using molecular compound way. So P2O5, I have P, which is phosphorus, O5, and it's going to be oxide. Agree? So we got to know the prefix is di, phosphorus, and 5 is pentaoxide. So that's how I would name it. Diphosphorus pentoxide, and that's the answer for that question. So if you have mono or penta, we usually drop it if there are vowels next to each other. So that's why I just, instead of pentaoxide, just call it pentoxide. CCl4, see how there's 1 carbon and then 4 chlorine. So chlorine will be called chloride, but there's 4, so we call it tetrachloride. And we don't call the first one monocarbon, we just call it carbon, because if it's mono on the first, if it's 1 on the first term, we don't use the mono. So it'll be carbon tetrachloride. Next question here. Name the following compound of S and O2. So S is 1 sulfur, 2 oxygen, so this will be dioxide, and S would be sulfur. We don't need the mono, so our answer is going to be sulfur dioxide. Next one, N2O5, we have 2 nitrogen, so dinitrogen pentoxide, because penta for 5. So dinitrogen pentoxide would be our answer for C. So let's talk about naming acids. Binary acids, they have to be in water, okay? So if it's in water, it's hydrochloric acid. And if it's not in water, we call it with the hydrogen ide name, okay? So it's not, when it's aqueous means it's in water, we will use the hydrochloric acid name. So let's learn about how we can name them. When we write the formulas, we always write the H first. So for naming binary acid in like this guy here, H and an ion here. So hydro and then the name chlorine, right? So we drop the ane, we have hydro and then chlor and then ic acid. So let's practice. If we have H2S, we have hydro. And then this is S sulfide, right? So we got to change it to ic acid, hydrosulfuric, because sulfur, and then we name it acid. So the final name would be hydrosulfuric acid. Next question, name the following acid. We have HI. So H is for hydro, right? And then iodine, so iodic, and then acid. All right, so here's the next one. We have H2SE. Se is selenium. So we would use hydroselenic and then acid. HF is hydrofluorine turns to fluoric acid. All right, so reviewing naming. Okay, so earlier we said if you have molecular compounds, they're going to be non-metals binding together, and we have to end IDE at the second compound. second element, and we use prefixes to name the first element and the second element except mono for the first element. For ionic compounds, we have two options. You remember we have metals with one type of cation that doesn't change its charge. We just simply use the name of the metal and the IDE for the nonmetal. And then we have the next one, we can use the Roman numeral for the cation charge and then the IDE for the nonmetal ion. And sometimes if you want to use the old name, which we don't in our class, you don't have to memorize the old name. The old name metal has us or ig depending on which one it is, and then the root plus iodide, IDE, ide for the nonmetal. We usually typically stick to the Roman numerals. Then we want to learn about naming the acids. Here's a review. Remember, if it's in water, that means AQ. If it writes something formula AQ, it will be hydro, the name ic acid. If it's not in water, like gas form or some other form, we'll use hydrogen and then the name IDE. So for example, if we have hydrochloric acid, it would be this formula because it's an AQ. If it's just HCl gas, it would be hydrogen and then chloride because it's in gas form. So name the following compounds CuCl2. So Cu and Cl2, we know that I have two chlorine ions, so chloride ions, Cl negative, and I have Cu. How do I balance it out? If I have two negative charge, my Cu would be 2 plus. So that's how I know my copper will be a 2 Roman numeral, so it's copper 2 chloride, because this is an ionic compound with variable charges. The next one, C3N2. C3 is carbon, is nonmetal, and then nitrogen is also nonmetal. So this is going to be the molecular formula where you use prefixes in each one. So for carbon, because there's 3, we call it tri for the carbon, and then for nitrogen it will be di because it's 2 of them. So it'll be tricarbon dinitride. Remember, we have to do the IDE at the end. So the next one we have ICl3. ICl3 is also a nonmetal and nonmetal, correct? So if it's nonmetal and nonmetal, we will be using our molecular compound naming, which means we have prefixes involved. But since we have only one iodine here, we don't need to use mono. We start with the iodine, and then we have trichloride. So iodine trichloride, my answer should be A. So this one here, HCl is an AQ, so this will be an acid. It will be hydrochlorine, so chloric acid. So hydrochloric acid, your answer will be C. So now we want to focus about polyatomic ions. That's the next part. You will have to start memorizing polyatomic ions so you know the formulas and the charges for these guys. So for example, here we have cyanide ion, Cn negative. And then if we want to name them, we name the cation and then the anion. So we have to start memorizing formulas for polyatomic ions, because without knowing the names, it will be really hard for you to put names together, correct? So we need to learn the names of polyatomic ions, recognize the formula and the charges. So we name the cation, and then we name the anion, and then we put them together. So here's a table of common polyatomic ions. You will need to make sure you memorize all of these. So for example, here we have acetate ion as C2H3O2 and -1 charge. So the charges are written out here for you, so you know. We have ammonium ion, NH4 positive. And then we have hydrogen carbonate. We talked about this. This was the ion in the baking soda. Ammonium is actually found in the ion here is found in in glass cleaner. Acetate is, it makes acetic acid, which is vinegar. So this is what the ion is in vinegar. It's pretty cool. And then we have these guys series here. We have hydrogen sulfate. So you gotta know that. And then you see how sulfate is right there, and then sulfide. So it's related. So if you have hydrogen sulfide, you just added the hydrogen sulfide will be H. Let's add it down. Hydrogen sulfide would be HSO3 -1 charge. Okay, so it's related here with hydrogen sulfate. You see how when you add an H, it loses 1 charge down, like it falls in charge. So if you have sulfate to hydrogen sulfate, it will be -2 for sulfate. Hydrogen sulfate will be -1. So if you have sulfite to hydrogen sulfide, you get a -1 charge, like it falls a charge. Okay, so you want to make sure you memorize what permanganate looks like, what chromate and dichromate looks like. This is chromate, that's dichromate, and then we have cyanide. Hydroxide is really common, so make sure you know that. Nitrates, like no nitrates in your food, that's this nitrate. Nitrite is 1 charge, so ATE and ITE is always like 1 oxygen difference. Okay, but both of these are going to be the same charges here. So that's the list here for some of your polyatomic ions. So let's talk about polyatomic ions that contain oxygen. So we end it in ATE or ITE if the names. If your ion names in ATE, ends in ATE, it has more oxygen atoms than ITE ones, like you can see in the previous slide. So it has multiple oxygens, multiple ions with oxygen prefixes are also needed. So per adds 1 oxygen to the 8th root. So per has the most oxygen. Hypo is subtract 1 oxygen from the 8th root. Okay, so then we have here, if we have ClO negative, ClO2 negative, ClO3 negative, see how the oxygen just keeps increasing? The charges are all still -1. Okay. So this one's name will be hypochlorite, and then you go to chlorite, and then you go to chlorate, and then you go to perchlorate. So you need to make sure you memorize the anion names for these series here. You can change it with Br or I. It would change the name to hyperbromite, bromite, bromate, and perbromate. So just basically change the root. If you had an acid, an AQ, this would be ite turns to us acid, and then I turns to us acid, ic, 8 turns to ic acid, and then C perchlorate, 8 turns to perchloric acid. So the naming system is still the same. So you need to know the polyatomic ion names. So this chart and the previous one. So here's the practice. You need to know the name for NaNO3. So Na is sodium. NO3 is -1 charge. Sodium is +1 charge because it's in group 1. So if you know that NO3 is nitrate, so our name, this is an ionic compound. So NaNO3 would be sodium nitrate. So our answer here would be C. So next one, KCN. We want to name it. So this again is an ionic compound, but it has Cn as cyanide. Cn is -1 cyanide ion, so it will be potassium cyanide. And potassium doesn't need a Roman numeral because it's in group 1. It doesn't change its charge, so it will be potassium cyanide. Answer D. All right, so the next one we want to do is LiClO2. So ClO2 was on our list earlier. If you memorize that chart, ClO2 is going to be chlorite. So we have lithium, which is group 1 that doesn't change, and we have chlorite. And because this is an ionic compound with no variable charge, we don't need a Roman numeral, so it will just simply be lithium chloride, which is LiClO2. ClO2. Our answer A. Lithium perchlorate. Remember, perchlorate would be ClO4. So LiClO4. And then hypochlorite is just one oxygen, so LiClO. And then chlorate will be 3 oxygens, so LiClO3. So you just need to make sure you memorize that series right there. Next one, NH4 is my polyatomic ion. NH4 is ammonium ion, and ammonium ion is +1 charge. You do not need a Roman numeral, okay, because it's not even a metal. So ammonium, and then I is iodide ion, so ammonium iodide is our answer, and our answer here should be B. So sometimes we have more complicated stuff. More complicated examples, we have more than 3 elements in them. So if we have more than 3 elements, we use the same way. We identify the ions, name them in order, cations first, and then the anions. Sometimes if you want to, instead of hydrogen sulfate, we can use bisulfate. So like hydrogen carbonate here, we can call it sodium hydrogen carbonate or sodium bicarbonate. Same thing, okay? So, and then you have NaHS, hydrogen sulfide. We just call it sodium hydrogen sulfide. So this will be magnesium, ammonium phosphate. And then this is sodium potassium sulfate. So again, you need to memorize your chart of definitely polyatomic ions, and you also need to memorize the metals that don't change charges. So the ones that change, you'll remember to put a Roman numeral on it. So let's try this one. It has Kal and SO4 too. So this is potassium, aluminum, and sulfate. Sulfate here, we don't need the prefix because this is not a molecular compound. So our answer here should be just plain potassium aluminum sulfate, A. Next, we want to do the next one. We have CaHSO3 and then 2. So this one was the one we talked about. It was sulfide, but we have a hydrogen sulfide, or we call it bisulfite. And then this is just calcium. So it'll be calcium hydrogen sulfide as our answer. So this would be B, or sometimes we can call it calcium bisulfite. So before this, we were naming binary acid. We have hydroic acid rules. Now we have oxy acids that have hydrogen, but it will have some polyatomic ions that usually have oxygen in there. So H is the first element. The compound will have polyatomic ion with oxygen in it. And then the way we name it is ATE ions always turn to ic acid. And then if you have ITE ions, it will be turned to us acid. So ic acid will contain more oxygen, one more oxygen than us acid usually, because of the way ATE and ITE ions are always going to be, ATE has more oxygen than ITE. So here's an example. We have H2SO4. I know SO4 is sulfate. So remember, we don't have the hydroic acid name because this is not binary. This is a oxy acid right here. So it'll be sulfate. And then we have, so sulfate will turn to ic, so sulfuric acid right here. Our answer would be in C. So for HNO2AQ, this is an acid, and this is a not a binary acid, but an oxy acid. So NO2 ion is nitrite, and if it's nitrite, we'll turn into nitrous acid, which our answer will be A right here. So we want to do a recap again on naming acids. First acid always begins with H, and then it contains oxygen. Anion contains oxygen. That means it's an oxy acid. So we check ITE ions will turn into us acids. And then ATE ion will turn to ic acid. And then if it doesn't have oxygen in it, it will be just a regular binary acid. We will use hydro and then whatever ic and then acid. And that's the review of our naming acids.